Okay, so yesterday we looked at designing an experiment, and we really looked at like with two groups only. So today we're going to look at more than two groups. I'm going to do a random number generator. So we're going to look at a little bit more complicated stuff, but the basics are the same. So we got two examples, and then the third example, I'm just going to kind of outline it. So the first one. If children are given more choices within a class of products, will they tend to prefer the product to a competing product that offers fewer choices? An experiment prepared 3 choice sets of beverages. The first has 2 milk drinks and 2 fruit drinks. The second has the same 2 fruit drinks but 4 milk drinks. The third had 4 fruit drinks but only 2 original milk drinks. The researchers divided 210 children aged 4 to 12 into 3 groups at random. They offered each group one of the choice sets. As each child chose a beverage to drink, the choice set was presented. The researchers noted whether the choice was a milk or fruit drink. So what are the experimental units or the subjects? So it is, be specific, it is the 210 children age 4 to 12. So you want to be specific. Okay, don't just say people. What are the factors and what are the levels? So the factors is the choice of drinks. Okay, and we have 3 levels. Level 1, you have the 2 milk, 2 fruit. Level 2, you have 2 fruit, 4 milk. And level 3, you have 4 fruit, 2 milk. What's the response variable? The response variable is their choice of beverage. So, thoroughly explain how you would assign the labels to the 210 children in the actual experiment and place them into treatment groups. Okay, so now we need 3 groups. So, we're going to use a random number generator because it's sort of like the easiest. I mean, you could use slips of paper too, I guess, but I wanted to show you what a random number generator sort of looks like because there's some like kinks to it. So I'm going to assign every child a number from 1 to 210. So using a random number generator, to select 70 numbers, I'm going to ignore repeats. These children are in group 1. Now, to get to group 2, instead of like trying to pick another 70 numbers, ignoring repeats and ignoring numbers already given, I'm going to renumber everybody. So I'm going to renumber the remaining 140 children from 1 to 140. Then I'm going to use a random number generator to select 70 numbers, ignore repeats again. These children are in group 2. The remaining 70 children are in group 3. So, the biggest difference is you have to renumber. Now, in order to assign treatments, I need to do a next step. So I'm still going to use a random number generator. Instead of flipping a coin, which you can't with 3 things, I'm going to use a random number generator again. So, in order to assign treatments to groups, use a random number generator. I'm just going to say we're going to use randint, parentheses 1, 3, so I'm only choosing from numbers 1 to 3. And whichever group number comes up first gets choice set with 2 milk and 2 fruits, that first choice set. Then I'm going to do it again. The next number, ignoring repeats, will get the 2 fruit, 4 milk choice set. The remaining group gets the 4 fruit, 2 milk choice set. Okay, so when you're doing assigning a treatment to more than 2 groups and you want to use random number generator, you just say from 1 to however many, and then whatever the first number comes up, then the next number that comes up, again ignoring repeats, will get the second one, and then the next number ignoring repeats will get the next one, and so on and so on. So it's a little bit more complicated with 3 or more things, but this gives you like a good idea of what that would look like. So the second one that we're going to do is we're going to look at you are participating in the design of a medical experiment to investigate whether a calcium supplement in the diet will reduce blood pressure of middle-aged people. Preliminary work suggests that calcium may be effective and that the effect may be greater for men than for women. So what we're going to do here is we're going to end up blocking on gender. Okay. So first thing, we're going to write a paragraph describing our design of our appropriate experiment. So here's one where we're going to have to end up blocking, and then we'll answer B after. So let's pretend I have 100 men and 100 women. So I'm going to use 100 male and 100 female subjects. First thing I want to do is measure their initial blood pressure. Okay, now, to block, we're going to block based on gender. So I'm basically going to describe how I would divide the male participants up into a control group and a treatment group, and then I'm just going to say repeat for female. So, assign each male a number 1 to 100. Use a random number generator to select. Now, if you don't want to ignore repeats, some students will do 50 distinct numbers. I hope I spelled distinct right. That distinct part basically means you're ignoring repeats. So that's one way to do it if you wanted to not write ignore repeats, because that's where people end up missing points. So that's another option. These men are in group 1. The remaining males are in group 2. Repeat this process for the 100 female subjects. So if you're going to block, explain what you would do with one block and then just say repeat with this other block. So now I need to assign treatments to groups. So I got 2 groups. I'm going to flip a coin. So for each block, flip a coin to assign treatments. If heads, group 1 gets the calcium supplement. If tails, group 2 gets the calcium supplement. Okay. The remaining group within each block will receive a placebo pill. So now we gotta wait 2 months, then measure the blood pressure of each individual and compare results. Okay, so blocking's not that hard. It's, again, a little bit more writing, but just explain what you do for one block, and then here I kind of said for each block, so I didn't have to go back and forth. Explain the advantage of using a larger groups of subjects. Choosing the size of the treatment groups requires more statistical expertise, which we do end up learning about later this year. But again, we talked about the other day for Part B, we want replication. What that does is it increases the reliability and reduces the effects of any confounding variables. Okay. Now the last one, we're not actually going to write it all out. What this one's looking at, a psychologist is interested in the effect of room temperature on the performance, requiring manual dexterity. She chooses 2 temperatures, and the response variable is the number of correct insertions in a 30-minute period with an elaborate peg and hole apparatus. Each subject is trained in the apparatus and then asked to make as many insertions as possible in 30 minutes. So basically what we can do, since we have 40 people? Yeah. So if I have 40 people, I could split it up 20 and 20. One to do the 70 degrees Fahrenheit room, one to do the 90 degrees Fahrenheit room, and then compare. But this is one where you could do a matched pair with yourself. So you could randomly assign people to a room, and then the next day switch rooms. So you're a matched pair with yourself. So that would be one where you could do a matched pair situation as opposed to 2 groups. I just didn't feel like writing it all out. I think you have an idea, but this is kind of generally what we would want to do. So gives you a couple more experimental design ideas. Like I said, on the test, you're probably only going to have to do one of these. So, or even if in the multiple choice, if I gave you an experimental design, could you explain that it's good or bad and why? So that's really it for Chapter 2, luckily. We'll practice some more, obviously, before the test, but this just gives you a general outline.